The basic form of an exponential function is y equals a times b to the x power. Does that look familiar based on what we've been doing the last couple days? Yeah. Yesterday, what did our b look like? We had to change it, right? We had to change it from just a number to being what? 1 plus or minus what? R, right? 1 plus or minus the rate. So our b can look different, but our b is our base that we're being raised to an exponent. That's how we know if it's growth or decay, right? Okay. A and b are constants. We know that. Okay. What effect do a and b have on the tables representing the function? So that's what we're going to figure out today. If you already know, then okay, let everybody else discover it with us. So, first thing we need to do is we need to fill out these tables. Okay, so we're going to fill out the tables all the way together, and then we're going to go back and look at all the A and B and stuff. Okay, so in your calculator, would you please put 3 times 2 to the x power and go look at the table? Does everybody remember how to do that? We're starting a new graph. And we say 3 times 2 raised to the x power. And we go Control T to look at the table. Right? So 0 is 3. 1 is 6. 2 is 12. 3 is 24. And 4 is 48. So, will somebody please volunteer to do number 2? Thank you, Presley. Who's going to do 3? Thank you, Allie. Who's going to do 4? Connor's 4. Who's doing 5? Adelaide. Who's doing 6? Thank you, Kate. Do those real quick. Once you get yours, tell me you're done, and then tell me the numbers, and I'll write them down. If you didn't volunteer to do one, I want you to do one anyways. What you got? Which one?
5 and 2.
Okay.
0 is 2. 1 is 6.
Okay.
2 is 18. 3 is 54. And 4 is 162.
162. Okay, thank you very much. Good job. What you got?
I have 3.
Yes?
0 is 1. 1 is 6. 2 is 36. 3 is 216. And 4 is 1296.
Very good. What you got?
I have 4.
Okay.
And 0 is 8. 1 is 4. 2 is 2. 3 is 1. And 4 is 0.5.
Thank you.
I have 5.
Yes, ma'am?
100, 50, 25, 12.5, and 6.25.
Thank you.
I have 6.
Yes, ma'am?
I have 0 is 200, 1 is 160, 2 is 128, 3 is 162.4, and 4 is 81.9.
What did you say 3 was?
102.4
102.4. And 4?
was 81.92.
Perfect. Okay, so do you guys have these written down as well now?
Yeah.
Okay. So let's go back up and look at number 1. Okay. Based on the fact that y equals a times b to the x, what is a? 3. And how do you know that, Robert?
I don't know. Yes. On the top of the page.
You just looked?
Yeah, I just looked.
You just looked, right? Because it's y equals a times b to the x. So it seems logical that a would be 3. And what's b then?
2.
2. Okay. How do we find a ratio? What are we doing if we're finding a ratio? We are dividing. What's 48 divided by 24? 2. What's 24 divided by 12?
2.
What is 12 divided by 6?
2.
2. What's 6 divided by 3?
1 versus 2.
Okay, so all we're going to say at this point is, how interesting. Say it. No, you have to do the, how interesting. All right, look at number 2. We're not making any conclusions yet. We're just saying, how interesting. Okay? Knowing what we know, y equals a times b to the x, what is a for problem number 2?
2,
And what is b?
3,
3. Okay? How do we find a ratio again?
divided.
Divide. Okay, what's 162 divided by 54?
3, 2, 3.
Pretty sure it's 3. What's 54 divided by 18?
3.
What's 18 divided by 6?
3,
And what's 6 divided by 2?
3.
Okay.
How interesting.
Knowing what we know about what it says up here, y equals a times b to the x, what is a?
6. 0. 0.
1.
1 is 1.
It is 1. How do we know which one is b? It has the x, right? It has the exponent of x. And if there's not a number in front, is it a 0? No, if it was a 0, 0 times anything is 0, so that would negate the whole problem, right? All right, ratio. What's 6 divided by 1? What's 36 divided by 6? What's 216 divided by 36? What's 1296 divided by 216?
6.
Okay, so just as a quick aside, I didn't see any of you pressing that into the calculator. So I'm thinking, hoping, that you're starting to see the pattern. So this one's done now, so now what do we say? Interesting. Okay. Knowing what we know from the top, y equals a times b to the x, what is a? 8. And what is b? 0.5. Okay, what's 4 divided by 8? 1/2. What's 2 divided by 4? 1/2. What's 1 divided by 2? 1/2. What's 0.5 divided by 1? Really? That's what you would say?
1.5.
You would say 0.5? I'll write down a half if that's what you want, but if I'm saying what's 0.5 divided by 1, I'm saying 0.5, right? Okay. So that one's done. So now, interesting. It's weird because it doesn't seem like you think it's all that interesting.
I don't like that.
You be quiet. Knowing what we know from the top, here's the equation. What's A? 100. And what's B? 0.5. What's 50 divided by 100? 1/2. What's 25 divided by 50? 1/2. What's 12.5 divided by 25?
0.5.
Okay. What's 6.25 divided by 12.5? 0.5. Okay. This is what I just heard. Interesting. Knowing what we know from the top, what's A? 200. And what's B?
28.
Okay. What's 160 divided by 200? 4/5. Okay. What's 128 divided by 160?
Probably 5.25.
What's 102.4 divided by 128? 0.8. And 81.92 divided by 102.4?
How weird.
Where does A show up in the table?
First,
Is that true? Is that true?
by my observation.
So x is 0. I said A was 3, and there's a 3. A was 2. I look where x is 0, and there's a 2. A was not there, so we assumed it was a 1, and I look in the table where x equals 0, and there's a 1. A was 8. I look at the table where x equals 0, and there's an 8. A is 100. I look in the table where x equals 0, and there's 100. A was 200. I look in the table where x equals 0, and there's a 200. So where is A in the table? Where x equals 0. What effect does B have on the value of the table? Is it? It's the ratio. Is that true? We said B was 2. Look at the ratio. We said B was 3. Look at the ratio. We said B was 6. Look at the ratio. We said B was 0.5. Look at the ratio. We said 1/2, 1/2, 1/2. But then we have 0.5. Aren't those all equivalent? We said B was 0.5. Look at the ratio. This was the hardest one, right? We said B was 0.8. Look at the ratio. You okay so far?
Yeah.
Okay. Then let's get some vocabulary in here. For functions in the form y equals a times b to the x, a is the it's the initial value or the starting value. A is the initial value or the starting value. What's B? The ratio. Also, y values increase when? When are y values increasing? What is? When b is greater than 1. And then I heard someone else say that's when it is growth. Excellent. When are y values decreasing?
When b is less than 1 but greater than 0.
Very good. Less than 1 or greater than 0. We also have been calling that decay. Very good. Can you go backwards?
Yes. Yeah.
Okay, what's 20 divided by 5?
4.
4. What is 80 divided by 20? 320 divided by 80?
4.
1280 divided by 320? You didn't even do that. You didn't even do it. I didn't see anybody punch that in your calculator.
We see the pattern.
We saw the pattern. Good. So in this particular problem, what is A? 5, and you knew that because you looked where?
Where x equals 0.
Where x equals 0, and what's B? 4. So what is the equation? Y equals 5 here and 4 here? 5 times 4 to the x power. Can you tell that that's a little tiny baby x?
Yes.
Okay, just making sure. Look at problem number 8. What's 18 divided by 2?
9.
What's 162 divided by 18? 9, okay. What's 1,458 divided by 162? 9. Thank you for those of you who are actually checking. 13,122 divided by 1,458? It is 9. So in this particular problem, what is A? 2. And what is B?
9.
So what is the equation? 2 times 9 to the x power. Very good. Okay. What about number 9? What is 24 divided by 16? 3 over 2? Okay. What is 36 divided by 24? 3 over 2. 54 divided by 36? 3 over 2. And 81 divided by 54? 3 over 2. So in this problem, what is A? And where did you get that again? Where x equals 0. And what's B? 3 over 2. Okay, so I need to address that. We have to talk about that, don't we? Some of you are like, no, we don't. It's obvious. But just in case it's not obvious, let's talk about it. What's my equation?
16 times.
Because this is what I heard.
Whoa.
Why are you woeing me as if I was a horse?
That's pretty much stuff.
Is that right?
No.
Or do I need to scratch this out and write 3 over 2?
Right 3 over 2. No, it's right.
Because they are the same, right? Do you prefer fractions or do you prefer decimals? I know which one you prefer, but which one is more correct? In this case, neither, right? Are there cases where the decimal makes more sense? Yes. We talked about that last chapter when we had answers like 12 over 7, and we're talking about time. 12 over 7 doesn't make sense to us for a time. We need it to be 1 point, whatever it was, right? That made more sense to us, okay? But either one of these are correct, okay? All right, look at number 10. What is 200 divided by 500? 2 over 5. What's 80 divided by 200? 2 over 5. What's 32 divided by 80? What's 12.8 divided by 32? Oh yeah, that's where it makes a difference, right? Because your calculator told you a different thing this time, right? Before it told you 2 over 5, 2 over 5, 2 over 5, but because there was a decimal involved, then it put the answer as a decimal. Is 2 over 5 the same as 0.4? Yes. So in this problem, what's A?
A is
500, and what is B?
2 over 5.
You want to use 2 over 5? Okay, so what's the equation? Y equals?
500 times 2.
Now, I'm guessing, because I can see it, that some of you have 500 times 0.4 to the x power. And what are you going to say to that? You're going to say, okay. Because aren't they the same? Okay. Look at these two over here. These two are separate over in this other box, right? Complete these tables. We're going to do this first one without a calculator. You ready? Because we're being brave and we're being comfortable with our numbers, right? If x is 0, what's 1 to the 0? Because what's anything to the 0? 1. What's 1 times 4? 4. What's 1 to the first power? 1 times 4?
4.
What's 1 to the second power? 1 times 4?
Is 4.
What's 1 to the third power?
It's
1 times 4?
4.
So what if B was equal to 1? What shape is this?
a circle.
Straight line.
What kind of a line?
Linear.
Oh, please don't say linear line, guys. That means the same thing. It's a very specific kind of line, though. If I went over 0 and up 4, and then I went over 1 and up 4, and I went over 2 and up 4, it is. It's a horizontal line for sure. Okay, that seems weird, right? Okay, what about this one? Negative 2 to the 0 power.
Wait.
Because what's anything to the 0 power? 1. 1 times 4.
This is Kingston.
Yes?
Is it Adelaide?
Yes, I do.
Are you please in office for just a moment?
Yes, ma'am.
Thank you.
Okay, anything to the 0 power? 1, so negative 2 to the 0 power is 1 times 4? 4. Negative 2 to the first power?
2.
Negative 2. Negative 2 times 4? Negative 8. Negative 2 to the second power, so negative 2 squared? 4. 4 times 4?
16.
16. Negative 2 to the third power. Negative 2 times negative 2 times negative 2.
Negative 8.
Negative 8 times 4?
Negative 32.
Negative 32. What if b was a negative number? That's weird. Control T. You don't have to do this if you don't want to. I'm going to do it because I want to show you. I'm going to say 4 times negative 2 raised to the x power. Wait. Oh, what did I do? Hold on. Control. Okay, wait for it. Wait for it. Wait for it. Wait.
I'm waiting.
Wait. Wait. There.
Whoa.
Oh my gosh.
You're woeing me again?
Oh, dang it. I'm sorry. Yeah, you should send me.
So is this really what it looks like? No, the calculator panicked.
Yeah.
It didn't follow rule number 1. You know what it looks like. It's just a point up there and a point down there and a point up there and a point down there. How do you think that's going to continue? Is that going to continue positive, negative, positive, negative, positive, negative? So it's going to continue going like this. The calculator panicked and tried to connect all those. That's what happened. Because when I first graphed it, it didn't have all these lines, did it? It just had the dots. It panicked. So why don't we use bases of 1, and why don't we use bases of negative numbers?
Because bad things happen.
They're stupid. Weird.
They're weird.
Whoa.
Whoa. So many times. So if I gave you a table, can you figure out the equation from the table?
Yeah.
By looking at what?
Good. 0.
The x equals 0 to get A, and by looking at the
Ratio.
ratio to get
B.
B. Do you have any questions?
No.